All right, guys, we are going to pick up at chapter 3 right now. If you're missing the chapter 2 last pages, they're in the exam review 1 video that I did. So exam review 1 goes through pages 1 through 4. But part of that is today's assignment. So if you're struggling with where that is, go into exam review 1 and it'll be at the end of that video. Because that first video I just did all of chapter 1, all of chapter 2. Now this video I'm going to do all of chapter 3 and all of chapter 4a. Okay, so here we go. Solving by substitution or elimination. So when you take a look at this setup, when it's y equals something and y equals something, when your y has been isolated like this, that is a great setup for substitution. So the thing is, if I know what y equals, for instance, 2x plus 8, I can say, well, if I know that's the value of y, then take out y in this bottom one and put in the 2x plus 8. So it'll be 2x plus 8 is equal to 3x minus 1. So we're going to take away the 2x and we're going to add the 1. So this goes away, that goes away. We are left with 9 is equal to x. Okay, so that's our x value. Then our y value comes from you plugging that back into either one of the equations. So you can either plug it in here or you can plug it in here. So y will equal, I'm just going to do the top one, 2 times 9 plus 8. So 18 plus 8, or 26. So you have an x value of 9 and a y value of 26, and that will be your solution. Okay. Moving on to number 2. And again, fast forward, slow down, rewind, jump ahead. You just need to do whatever you need for help. Okay, so this one, when it's set up in standard form like this, it's a little more geared toward elimination. So I would do elimination on this. And if you recall with elimination, I said it's best if you always add your things together. So we try to make our coefficient to one of the variables opposites. So for instance, right now you see a 2x and you see a 2x. Now technically you could subtract, but when you subtract the whole equations, then minus a negative for this second part would become plus a positive. So that's why I don't love to do that, because people often forget that and then they get the wrong thing. So instead, what I would do is I would take one whole equation and I would multiply it by -1. So I'm just going to do it with the top one. Okay, that gives me a negative 2x, a positive 1y, and a negative 2. So essentially, I'm just not using that one anymore because I multiplied that top one by -1. And now I can take this whole thing and add them together. So 2x plus a negative 2x is 0. Negative 2y plus 1y is a negative 1y. And 4 plus negative 2 is 2. And then we'll just divide by the -1. So our y value is going to be a -2. And then you can take that and plug it back into whichever one you want. I'd probably do this one. So that's 2x minus your y value. So minus a -2 equals 2. Minus a negative is plus a positive. So I get 2x plus 2 equals 2. And then we subtract the 2. So 2x equals 0, and then we divide by 2. So x equals 0. So your point, your solution, would be 0, -2. And again, I am not picky on this part of it. If you leave it like this, x equals y equals, I'm fine with that. All right, so this one, again, I would make them opposites. You could subtract them, but I just like to make them opposites. So I would probably do the same thing. Again, I would multiply this top one by a -1. So -1 times a negative x is a positive x. negative 1 times a positive y is a negative 1y. And then negative 1 times 2 is a negative 2. So essentially I'm ignoring that. And I'm doing elimination with these two equations. So now we're going to add them together. 2x plus 1x is 3x. Y plus a negative y is 0, so that goes away. Negative 1 plus negative 2 is negative 3. And then we divide by 3. So x is negative 1. And then we're just going to plug that in to whichever one we want. I'm just going to go right here. So 2 times negative 1 plus y equals negative 1. So negative 2 plus y equals negative 1. And then we're going to add 2. So y equals 1. If you want to write it as a point, you would get the point negative 1, 1. Okay. Moving on. Now it's graphing. And remember, graphing inequalities, these are the ones that we shaded with. So you kind of graph it like it's a line, but then shade and do dotted versus solid. Maybe you want to just make a little note to yourself. These guys are dotted lines because they are not including the line itself. These ones are solid lines. They would include the line in the answer. So if I graph this top line, remember we start with the y-intercept. So this is in slope-intercept form. We're going to go down 5. 1, 2, 3, 4, 5. And then your slope is 1. So you're going up 1 over 1 as many times as you want. This is a greater than. So this is going to be a dotted line. Okay. And then if you recall, I always plugged in the point 0, 0 to check the graph. So I'm going to take this equation and plug in 0, 0. So 0 is greater than 0 minus 5, which means 0 is greater than negative 5. If that is true, which this one is, then you're going to shade where 0, 0 is. So I would take, and if you remember, I did this with just like bars, right? I did perpendicular to that. I did all this shading. And then when I did the other one, I went the other way so you could see where the overlap was. So that would be your first graph. Your second graph, I would put this one into slope-intercept form. So I would take away 3x from both sides. So you get y is less than or equal to negative 3x minus 2. So y-intercept of negative 2 would put you here. And then a slope of negative 3 is down 3 to the right 1. Or you could go up 3 to the left 1. 1, 2, 3, 1. This would be a solid line because it has that equal to bar. Okay, and again, now if we plug in 0, 0, 0, 0 is right there. If you plug in a 0, 0, either to the original or to your new equation, I'd probably do it in the original just to be safe in case you messed something up. 3 times 0 plus 0 is less than or equal to negative 2. So 0 plus 0 is 0. 0 is not less than a negative. So if 0, 0 is not true, then you shade away from 0, 0. So we're going to shade away over here. Okay, which means our solution, which if you want, you can just shade the solution part as well. It's just good for me to be able to tell where your overlap is. So this is the overlap. If you have your check marks going, I should be able to see where that overlap is. So you don't have to shade it with a highlighter, but just make sure I can see where your answer is. Okay, number 5. So this top equation, that's in slope-intercept form. So you're going to plot your y-intercept up 2, and then a slope of 1. So up 1 over 1. This is going to be a solid line. So it's going to look like that. And then plug in 0, 0. So 0 is less than or equal to 0 plus 2, which means 0 is less than or equal to 2. That's true. So you're going to shade the 0, 0 side. which would be down below. Okay, so that's the first line. The second line, do you remember absolute value with graphing? This should be a V shape, right? Either right side up or upside down. This one's going to be right side up because your A term is a 1, which is positive. The -3 is going to move us to the right 3. And then the +1 is going to move us up 1. So I'm going to go right 3, 1, 2, 3, up 1. That's going to put me right there. And then from that point, now you're going to do your A value. So up 1 over 1, but in both directions. So this way also, up 1 over 1. This is going to be a dotted line because it's less than, or sorry, it's greater than. So dotted line. Okay, and then if I plug it into 0, 0, y is greater than the absolute value of 0 minus 3 plus 1. Sorry, 0, not y. So 0 is greater than, this is 3, right? -3, but take the absolute value is 3 plus 1 is 4. Z is not greater than 4, so we don't want to shade towards 0, 0. So we want to shade away from 0, 0, which in this case would be here in that graph. So your answer would be all of this overlap. Okay, but I want to see it all. Don't erase any of the other stuff. I want to see where the overlap is. I want to see the other stuff that you have. Okay, number 6. You have 10 fewer quarters than dimes and 5 fewer nickels than quarters. Total value of coins is 475. How many quarters, nickels, and dimes do you have? You only need to set this up. You don't need to solve it. Okay, so your equations, I would start with the total number of, or amount of money. So 25 cents would be 0.25 for quarters. And then nickels, so that would be, well, here, quarters, nickels, dimes. I'm going to go in numerical order. 0.1 for dimes. Okay, if you want to put the D there, you can. And then 0.05 for nickels. Should total $4.75. So just make sure when you have dollars, right, the money part of it, that this represents the money part of it, not how many of them there are. So that would be your first equation. And then you have 10 fewer quarters than dimes. 10 fewer quarters than dimes would be, the way I would do it is the amount of dimes minus 10 would be the number of quarters you have. That would probably be the way I would set it up. You could also do D equals Q plus 10, right? If we move that 10 to the other side. And then the other one, 5 fewer nickels than quarters. So quarters minus 5 would equal the amount of nickels you have. So that would be your setup for that. You don't need to solve it. You just have to set it up. So there's your setup. Call it good. Okay, number 7. This is the fancy one where you have 3 different variables. So it requires a little bit of extra work, but the beautiful thing on this one is you actually have an easy jumping off point, right? These are all z's or negative z's, so we can do some elimination with that pretty easily. Excuse me. So here's what I'm going to do. I'm just going to copy these top 2. Okay, and I'm going to eliminate z. So we can add these together. 5x plus 2x is 7x. 4y plus a negative 2y is a positive 2y. This is 0 equals 2. Okay, so that's going to eliminate that. Then I'm going to take that top equation and I'm going to take the third equation. Okay, and then I can eliminate there as well. So if I add these together, 5x plus a negative x is 4x. 4y plus a negative y is 3y. This is 0 equals 3. So now you have 4x plus 3y equals 3, 7x plus 2y equals 2. Now we need to get rid of another variable. And I would probably get rid of the y's next. So 2y and 3y, if I multiply this whole equation by 3, and I multiply this whole equation by -2, then that'll get me a positive 6y and a negative 6y. So the first one here, I would get 21x plus 6y equals 6. When I go here, I get negative 8x minus 6y equals a negative 6. Okay, so now we're there. Your next step now is to eliminate with that. So if I add these together, 21x plus a negative 8x is 13x. Negative 6x and a positive 6x is 0 equals 6 plus a negative 6. We can't just like scratch it out because there's nothing over there otherwise, so we just need to put the 0 in there. And then to solve it, divide by 13. So x equals 0 divided by 13, which is 0. Okay. So now we have our x. Now we can plug that back into one of the pink equations up here to solve for y. So I would probably go here. So that's going to be 7 times 0 plus 2 times y equals 2. So this is 0. So 2y equals 2, and we divide by 2. So y is 1. Okay, so now we know our x value, we know our y value, we just need our z value. I'd probably plug it into this bottom one. So a negative 0, which is just 0, minus 1 plus z equals 2. So this becomes negative 1 plus z equals 2. We're going to add 1, so z is 3. So in the end, we get as an answer, x is 0, y is 1, z is 3. But again, if you want to just leave it like these, that's totally fine. Okay. All right, number 8. Which is a solution to the system of inequalities? You have a couple options here. You could plug in values for this, or you could solve. Like, for instance, if I take this and I add 4 to both sides, this is saying y has to be greater than 4. Well, the only one of these that has a y value that's greater than 4 is this one. So that's really the only option. But you could also just plug in 3, 3 to both of them, and negative 1, 2 to both of them, and 1, 5 to both of them, and 0, 2 to both of them. So you could plug them in. You could graph them. I think if you just stop and look at what this first one is saying, your y value has to be greater than 4. Therefore, the only one that has a y value greater than 4 would be that guy. All right, number 9. This involves something that gets done wrong so many times. Your a value is a negative, and you are squaring it. That should become positive every time. So 3 times negative 2 squared minus 2 times negative 2 plus 1. If you want to play this safe, plug it into your calculator how you see it right now. If you want to work out PEMDAS, negative 2 squared is 4. So 3 times 4. This is negative 2 times negative 2 is a positive 4 plus 1. So this is 12 plus 4 plus 1. So 16 plus 1 is 17. Okay. So that's chapter 3. On to 4a. 4a, it says sketch a graph of the quadratic function with the given vertex through the given point and write the equation. So you have a vertex at 3, 4 and a point at 5, 8. If you recall, vertex form looks like this. Okay, so that's what we're going to be using here. Your vertex is your HK. your point is your x, y, and we're gonna try to put it into that form. So we have to solve for a before we can plug it back in. But we know our answer is gonna look like this. So some a value times x plus or minus something squared plus or minus something. So we want x and y in our final answer. If I set that up with the vertex right now, it would be the 3 goes here and the 4 goes here. But then we also have our x and y. So the y is going to go here. The x is going to go here. So it's going to be 8 equals a, which we don't know. X is 5 minus the h value, which is 3 squared, plus the k value, which is 4. So simplify that. 2 squared is 4. So this is 4a plus 4 equals 8. Take away the 4. So 4 equals 4a, and then divide by 4. So a is 1. Okay, so that's what's going to go here. Technically, you don't need to put anything there, but if you want to put the 1 there, that's fine. And then plug the vertex back in. So x minus 3 squared plus 4. So this would be your equation. Okay, I put the graph there just in case you wanted to see it, but you don't need to graph anything on that one. You just had to write the equation. Example 2 says, given the parabola, find the axis of symmetry, vertex, all the pieces of that. If you recall, when finding the axis of symmetry, this is the one where x equals negative b over 2a, okay? So that's where you're going to start, because your axis of symmetry is always x equals something. So we got to figure out what negative b over 2a is. B is negative 4, so a negative b is a positive 4 over 2, and then your a value here would be 1. So 4 over 2, or 2. Okay, so that's your axis of symmetry. Your vertex is 2 something, and we figure that out by just plugging it in. Sorry, right there. So this is going to be y equals 2 squared minus 4 times 2 minus 3. So 4 minus 8 minus 3 is negative 4 minus 3, which is a negative 7. Okay, so your vertex is at 2, negative 7. Okay, if you recall, in this form, you can actually see your y-intercept right now. Your y-intercept is always that c value. So 0, negative 3, or you can just write it as negative 3 is fine. If you don't remember that, you can always find a y-intercept by plugging in x equals 0. Okay, so if you plug a 0 in for your x, you will always get a y-intercept. So let's take a look at this. If my axis of symmetry is 2, x equals 2, that's this line right here. Okay, the vertex is 2, negative 7. So 1, 2, 3, 4, 5, 6, 7. Y-intercept is 0, negative 3, 1, 2, 3. And we can reflect that to the other side. So it's 2 to the left of our axis of symmetry. We're going to go 2 to the right. And then you can do that 1 as your a value as a slope 1 time. So up 1 over 1 would be up 1 over 1 here. So the graph is going to look something like this. Okay. Your minimum is the y value. That's the y value of your vertex. So your minimum is negative 7. Domain is all real numbers every time. And then the range, your y value has to be greater than or equal to negative 7 because nothing goes below negative 7. So that'll be your range. And you're done. All right, number 3, they give you this parabola, but in vertex form this time. So your vertex, if you recall, comes from those 2 values. This is your h and your k. But it's opposite of what it looks like when it's inside the parentheses. So your vertex here should be a negative 2. And then positive 1. Sorry, negative 1. That one is the same as what it looks like. So negative 2, negative 1. So it's opposite on the inside. It's the same outside of the parentheses. Okay, so negative 2, negative 1, which means your axis of symmetry is x equals negative 2. So that's this line right here. It's always the x value of your vertex. Negative 2, negative 1 is that point. The y-intercept on this one, you have to plug in 0. You can't just pick the number that's sitting there. So it's going to be a negative 0 plus 2 squared minus 1. So 2 squared is 4. So this is a negative 4 minus 1, which is a negative 5. So this is going to be 1, 2, 3, 4, 5 down. And then we're going to reflect that. Okay. Now, your a term is essentially a negative 1. So you can go down 1 to the right one, down 1 to the left one time. And then your graph will be that parabola. All right, that means our maximum is the highest y value, or this number for your vertex, so negative 1. Domain is always all real numbers, and the range is y is going to be less than or equal to, because it's opening down, that maximum value, negative 1. Okay. All right, then we have some factoring. We'll see how much of this I get through right now. So when you factor this one, notice there's an x squared, there's an x, and there's a y. So this one doesn't factor very far at all. You do have a 4, an 8, and a 12, so you can factor out a 4. And what you're left with is x squared plus 2x minus 3y. But there's nothing more you can do since there's an x and a y. Yeah, that's as far as we can go. So this would be the factored form. Number 5, you are doing star method. What can you multiply to get a negative 24 that you can add to get a negative 10? Your a value, right, that's this guy, is 1. So that's going to be be careful with this one, because people see this and they go, oh, 6 and 4 gets you 24 and 6 and 4 gets you 10. That's not actually it this time. It's negative 12 and positive 2, because you need a negative and a negative. So this would be x minus 12 and x plus 2. And notice this did not ask you to solve, right? It just said factor the polynomials. So we're not solving like we did in 4b or 5. We're just factoring it, okay? Number 6, this one you should have pulled out a GCF first. So pull out a 2, you're left with x squared plus 2x minus 15. And then star method says, what can you multiply to get a negative 15 that you can add to get 2? Your a term now is a 1, because we're using this to factor. So 1 and 1, that's going to be a positive 5 and a negative 3. So don't forget about your friend, the 2 out in front. 2 times x plus 5 from this guy, x minus 3 from that one. So this would be your factored form. All right, number 7, no GCF on this one. So we're going to multiply a times c is 40. Your a term is 5, and then you have a negative 22 here. So you're asking yourself the question, what can I multiply to get 40 that I can add to get negative 22? And that's going to be a negative 20 and a negative 2. This you can reduce, right? So if you divide everything by 5, that's 1 over negative 4. So we're going to use this, and we're going to use this. So this is x minus 4 times 5x minus 2. And that would be your factored form. And I need to go teach. I'll come back in a little bit. Okay, I'm back. On number 8 here, we would factor out a 3. So we're left with 3x squared plus 2x minus 8. And now you can do star. So you're going to do 3 times a negative 8 is a negative 24. Your a term is a 3 now. and your b term is a 2. So what can you multiply to get a negative 24 that you can add to get a 2? That's going to be a 6 and a negative 4. And then that can reduce to 1 over 2. So don't forget about your 3 out in front. Then it's x plus 2 and 3x minus 4. Okay. On to number 9. This is a difference of squares. And if you remember, the shortcut for difference of squares is one is going to be plus and one is going to be minus, and you're going to square root both parts. So the square root of 9x squared is 3x. That goes in front. The square root of 100 is 10. That goes in back. And that's it. If you wanted to do star, you could say, what can I multiply to get negative 100 that I can add to get 0, because there's no b term there. But you don't need to. Oh, one sec. Okay, sorry. I just keep getting interrupted. So number 10 here, you have to factor out a GCF if you can, which in this one you can. So your GCF would be 2, and you end up with 9x squared minus 4. And then from there, that's a difference of squares again. So 2 times, one would be plus, one would be minus, and we take the square root of each. So that's 3x. And then the square root here is 2. So you end up with this as your answer. All right. Number 11, if you notice on this one is a perfect square trinomial. Okay. So the perfect square trinomial is the one where it's going to be something with subtraction or addition. This one's subtraction because that's subtraction. And then you take the square root of each. So this is going to be x. The square root of 100 is 10. So that is your answer. Again, if you didn't do it that way, you could set this up as star method. And it would be, what can you multiply to get 100 that you can add to get negative 20? You could totally factor it that way. You'll still end up with this as your answer. All right, and then number 12. This one, I feel like people at first think, oh, I can factor out a 4, but 25 doesn't have 4 as a factor. So you actually can't, but you do see that this is a perfect square and this is a perfect square. So when you take those square roots, you get 2x and 5. And remember, if it's 2x times 5 times 2, that equals this, then it checks out. So that's 20x, and this is 20x, so that works. So this is actually another perfect square trinomial. The minus should be a minus, and then we square it. So it looks like that. All right, that gets us through 4A. So this is 3 and 4A completely done.